In this video, I'll show you how to inverse a 3 by 3 matrix using the transformation method. The rules to using the transformation method are outlined below, and our goal is to convert this 3 by 3 matrix into its identity matrix, which looks like this. Let's analyze our matrix for a moment. Notice that our original matrix already has 1 in the correct position and these 2 zeros in the correct position. So technically, we have to change this 4, 6, 1, 2, 3, and 5. How many numbers are there? 1, 2, 3, 4, 5, 6. So you should have this transformed in 6 or less steps. The first thing that I'll do to tackle this matrix is to convert this 2 into a 0. And I can do that by multiplying row 1 by 2 and then subtracting row 1 from row 2. Since only row 1 is being amended, rows 2 and 3 will remain the way they are. So let's rewrite rows 2 and 3 since they won't be changed. And I'll multiply every number here by 2 and then subtract that product from row 2. 1 times 2 is 2. Subtract 0 is 2. 2 times 2 is 4. Minus 4 is 0. And lastly, 2 times 3 is 6. Minus 5 is 1. The next element that I'll target is this 1. And I can target this element by multiplying all of row 3 by 2 and then subtracting row 3 with row 1. This means that only row 3 will be amended, everything else will remain the way it is. These two rows have not changed. Multiplying this by 2 and then subtracting it from 2 gives us 0. Multiplying this by 2 gives us 0, subtracting from 0 is still 0. 12 minus 1 is equal to 11. Next, I'll try to target this number. And the way I can make this 5 into a 0 is by multiplying row 2 by 11, row 3 by 5, and subtracting row 2 with row 3. Let's go ahead and do that. The only row that will be changed is row 2, so I'll rewrite everything that will not change. Row 2 multiplied by 11, so that 0 times 11 is 0. 0 times 5 is 0, so that remains 0. 4 times 11 is 44, and 0 times 5 is still 0, so this becomes 44. And lastly, this becomes 0 because that's 55, and 55 minus 55 is 0. So we're getting awfully close to getting what we want. Notice that the only element we have left is this 1, and the diagonals are easy. So our last step is to make this 1 into a 0, and we can do that by multiplying row 1 by 11 and subtracting row 1 with row 3. Let's rewrite everything that will not change, row 2 and row 3. 2 times 11 is 22. 22 minus 0 is 22. 0 times 11 is 0, and so therefore we end up with 0. Lastly, 1 times 11 is 11. 11 minus 11 is 0. Dividing row 1 by 22, row 2 by 44, and row 3 by 11, we get our identity matrix. Now, to get the inverse, we have to perform all of these steps to the identity matrix. Let's start with the first thing we did. We multiplied row 1 with 2 and then subtracted row 2 from row 1. This means that these two remain the way they are, and the first row becomes 2, negative 1, and 0. Then we multiplied all of row 3 by 2 and subtracted the products of row 3 from row 1. That gave us 2, negative 1, and 0. That didn't change. Neither did this, but row 3 did, and it became negative 2, 1, and 2. Then we multiplied row 2 by 11, row 3 by 5, and subtracted the products of row 2 from row 3. And that gave us 2, negative 1, and 0, 10, 6, and negative 10, negative 2, 1, and 2. Notice that only row 2 changed. Then we multiplied all of row 1 by 11 and then subtract the products of row 1 from row 3. That gave us 24, negative 12, and negative 2, 10, 6, and negative 10, negative 2, 1, and 2. Notice only this changed. And lastly, we divided this by 22, this by 44, and this by 11. That gave us 24 over 22, which becomes 12 over 11. Negative 12 over 22, which became negative 6 over 11. And negative 2 over 22, which became negative 1 over 11. All I'm doing is reducing these fractions. And for the next two rows, I'll show you the reduced fractions. 5 over 22, 3 over 22, negative 5 over 22, negative 2 over 11, 1 over 11, and 2 over 11. This right here represents the inverse matrix for this original 3 by 3 matrix. And there you have it. That is how to inverse a 3 by 3 matrix using the transformation method.